screen here.
Oh, that would be good if you could.
Yeah, I'll go and get it.
Do I need the Q&As up, Nick, or do I just enjoy the show?
No, hopefully Janice can manage that and she'll ask her them. Right. I'm just starting the YouTube. Oh, gosh, blimey. Okay.
Careful what you broadcast.
Yeah. Okay. So we should be live on YouTube now, in theory, if Andy has taught me all he knows. So you've got my video. So on the live stream, actually I can watch it, can't I can put the YouTube on another screen so I can see what's going out. It's about 5 seconds behind, which is a bit disconcerting, but okay, where are we? 3 minutes to go.
Let me just find where we are on YouTube.
Oh, it says, I've just had a thing saying Stuart Moore raised his hand. Was that an accident, Stuart? I'm not sure what to do about it.
Yeah, because he's not appeared on the question.
If you got a question, Stuart, could you type it into the Q&A or the chat box? Or if you just press the wrong button. It's complicated, this. Don't whistle, whoever it is.
Pardon?
It was a very tuneful whistle.
Well, it was, but
I thought it was that bird.
I've had little robins sing to me all day.
Wow.
Right. Here we are. Oh, that's handy, Andy.
Liz saw a Merlin today.
Is that a wizard
Really?
of some kind?
No, it's a bird of prey.
Oh.
Thank you, Hewitt. That was the Brahms, actually, that I'm learning for your benefit.
Yeah, we're going to have to ban Hewitt from this if he starts sending messages like that.
No doubt he'll be drinking.
Hi, Honor. Right, let me just open up the... So where do the questions appear on the YouTube bit?
So Nick's giving the cricket score now, which is very helpful.
Yeah, it was going well. We're going to win. Technical question. Where do the questions appear on the YouTube side?
I don't know. I guess they'll probably just appear in the comments, won't they? Probably. So that thing where Honor has just said, yep, live on the live chat, Janice. I think it's there. Can you see that?
Oh, on the... I don't see her on the webinar chat.
No, on the YouTube.
Okay, right.
So if you can just keep an eye on both of those.
No, don't start yet. I haven't found it.
No. Okay. Okay, so I'll just start doing, it's almost 7 o'clock, so let's give it another minute or so before I get going. Okay, so I'll just start doing.
Interestingly, there's a delay of about 1 second, 2 seconds with the YouTube.
Yeah, I think it's even longer than that. It's so you want the audio turned down, otherwise you'll get a very disconcerting echo coming back.
Yeah, right.
Okay, I think time to get going if everybody's ready. So welcome everybody to this Wednesday evening BAA webinar. This is my third one. But it's rather different to the previous two, because the previous two were hosted by Andy Wilson, who is the person in the BAA who's responsible for setting all of these up. So he's the guy who did all of the hard work to get these webinars going. Surprisingly, he's got other things that he needs to be getting on with. And so now we've dropped the frequencies of the webinar a bit. There are going to be occasions when he's not hosting, Dominic is still around, and Dominic will be hosting some of the webinars, and I'll also be hosting some. And we decided that this one we'd give it a go where I actually hosted my own webinar. So I'm in complete control of what's going on, and anything that happens now is entirely my responsibility. So over the next half an hour or so, I just want to run through some of the observations that we've received in the BAA of Comet Neowise 2020 F3, and try and answer the question about whether it really is a great comet or was a great comet compared to some of the comets we've seen in the past. And I'll be helped in that by Dennis, who's seen a lot of comets in the past, but actually because he lives in the north of Scotland, didn't actually get to see very much of this one. So the comparison for Dennis is going to have to be based on the on what we see over the next half an hour or so. So let's get going. This title slide, I think, is one of the most beautiful pictures that we had submitted to the BAA by Rob Bullen. It's from the Forest of Dean in Gloucestershire on the morning of July the 11th, which I think a lot of us will remember as being an amazing night, the 10th, 11th and the 11th, 12th of July with the comet and noctilucent clouds in the sky. And I just think this is a wonderful evocative picture of nature with the mist rising over the lake there, the NLCs in the sky, and Comet Neowise 2020 F3 with its lovely dust tail. So where did it all start? It all started with the launch of this spacecraft. This is the WISE spacecraft, the Wide Field Infrared Survey Explorer spacecraft. It was launched back in December 2009, quite a long time ago. And it's an infrared satellite, and it was originally intended as a wide field survey infrared satellite, which was capable of taking infrared images at some very long wavelengths. Because at those long wavelengths, you need the detector to be very cold. It was launched with, I think, frozen hydrogen coolant. And that coolant, like most of these infrared satellites, ran out fairly rapidly. And so after about a year or so, as expected, the coolant wasn't able to keep the instruments cold enough to use the longer wavelengths. And so they put the spacecraft into hibernation. But then there was a proposal, because it was very good at discovering near-Earth objects, there was a proposal to use 2 of the wavelengths nearer to optical wavelengths as a survey for NEOs. And so it was rebadged Neowise, the Near-Earth Object Wide Field Infrared Survey Explorer. And that's what it became. So Neowise was scanning the sky for near-Earth objects. Now this year we've had what potentially were 3 good comets. So when we look for a comet that could potentially be bright, what we're looking for is a comet that looks healthy, is brightening fairly rapidly, but also has a small perihelion distance. So comets that when they're discovered have small perihelion distances become candidates for comets that could be quite bright, because generally comets become bright quite rapidly as they approach the sun. They get strongly heated, and that causes the outgassing and the dust to come off them to cause them to be spectacular in our skies. And there have been 3 comets this year that could have done that. The first one, which was the subject of my first webinar, 2019 Y4 Comet Atlas, which, if you remember that webinar, we were predicting possibly that it could become quite a nice object in the May evening sky. Well, immediately after that webinar, it fell to pieces. Very interestingly, and there was an article that we put in the journal, we had a very good view of its disintegration, but it meant that the comet wasn't very bright when it finally got near to perihelion. There was another comet which you may or may not have heard of much of. That was Comet 2020 F8 Swan, which again had a fairly small perihelion distance of 0.43 AU. That one again was predicted that it could be quite nice in the morning sky in kind of May, but that one also disintegrated. So 2020 F3 Neowise, which is the subject of this webinar, is the one that survived and the one that did good. When it was discovered, it was quickly determined that it had a perihelion distance of 0.29 AU. So it looked healthy coming in close to the sun. And it was in an orbit that meant that when it was close to the sun, going through perihelion, that we in the northern hemisphere would have a good view of it. So initially it was only visible from the southern hemisphere, but at the time after perihelion, when we expected it could become quite bright, it was reasonably well placed for us in the north, or as well placed as any comet can be in the middle of the summer when it doesn't really get dark around midnight in June and July. So if you remember back to that first webinar I did, which happened to be on the 1st of April, in the discussion afterwards, we were talking about this newly discovered comet 2020 F3, and John Drummond was on the webinar, and he actually said, "Oh, I've just taken an image of it." And so this is an image that John took from New Zealand, because the comet was only visible in the southern hemisphere, when it was around about 15th magnitude or so, just after discovery. And we didn't really know how it was going to behave. By this time, we knew it was going to come in close to the sun, but we had no idea really whether it was going to be a bright comet or not. So it was followed through the southern hemisphere. We couldn't see it from here because it was too far south. And Michael Matasio in particular took images of it fairly regularly. And as they lost it in the southern hemisphere in the middle of June, it disappeared into their evening twilight. Michael said he posted a message on a Comet forum saying that the comet looks healthy and he thinks it's going to be third time lucky for observers in the northern hemisphere. And what he meant by the fact the comet looked healthy is that the coma here, the head of the comet, still looked nice and symmetrical. It hadn't turned into the kind of teardrop or pear shape, which is the kind of sign that the comet is disintegrating. The comet was brightening nicely. It appeared to be a robust and active comet. We knew that it had been to the inner solar system before. It had an incoming orbital period, I think, of about 4,500 years. So 4,500 years ago, it would have been in the inner solar system before. So it was showing all of the good signs that it could be bright. But given my record of predicting bright comets, I didn't want to jinx it. So there wasn't much on the BAA website really until we really were sure that it was going to be a good object in the northern hemisphere. And also the media, you may have noticed, the media always like to report comet of the century stories. The media were really quiet about this one as well. Maybe they'd been burnt by the previous two. So it had disappeared from visibility in the southern hemisphere. The next we saw of it was in the coronagraph of the SOHO spacecraft, which is the venerable spacecraft that was launched, I think, back in the early 90s. It's been there for almost ever, looking at the sun. And this is the wide field coronagraph. This is the C3 coronagraph. And the comet moved through the field of the C3 coronagraph, and you can see it here. It was looking healthy, it was brightening, it was really looking encouraging at this point, but we still really didn't know how it was going to perform when it finally became visible in our skies. What we did know is where it was going to go. That's the one thing we can predict about comets. So we knew that it was going to become visible to us probably around the time of perihelion, around the 3rd of July, although it would be very low in the morning twilight. It would then track up through Auriga under the pole through Lynx, and so it would change from being best in the morning sky to the evening sky. It would then go into Ursa Major, and it would reach its closest point to the Earth on July 23rd when it was in Ursa Major, and it would then move away from both the Earth and the Sun, fading out as it moved into Coma and Virgo. So for those of us in the UK, we were really well placed to see it, as long as it was going to be bright enough to be seen against a reasonably bright twilight sky. The further north you went, the higher the comet became, but also the brighter the sky became. So getting the comet from Scotland was more of a challenge, and from the north of Scotland, where at that time of the year the sky hardly ever became dark, you were never going to get the best views. But from the south to middle England, those kind of latitudes, we would get a pretty good view. So it all depended on what the weather was going to be like. And these are 4 Meteosat pictures of the weather over the UK on mornings from the 3rd of July through to the 12th of July. The 3rd of July, which is our first possible opportunity to see it, there was a lot of cloud around. I live about here, and there were some clear patches on the 3rd of July. The 6th of July was much better. It was clear over much of southern and eastern England over to western England, a few clear patches in the borders and up into Scotland, and also around Dublin and into Ireland. The next night, the 7th, it was cloudy over much of England, but there were tiny clear patches, and I lived just under one of those clear patches, so I was incredibly lucky on the 7th. But the night that nearly everybody saw it, who got good views of it, was the first night they saw it was on the 11th, 12th, when it was clear over much of England and Wales, up into Scotland as well, and clear up the east coast of Ireland and clear on the northern coast of Ireland as well. So people really got good views then. But so at this point, we didn't know how bright this comet was going to be. We thought it was going to be good. We'd read some reports on the 3rd of July that people further south than us in the US and around had actually seen the comet at maybe first magnitude. So on the morning of the 3rd of July, I tried to get it. I couldn't find it in binoculars, but I think I managed to get it in images. I think this very faint object that you might be able to see here between the white lines, which is just off from this tree here, is Comet Neowise. This was on the day of perihelion. I think if this is really an image of it, it's probably the first image from the UK. I'm happy to be contradicted in that, but I think this is the first image of it, but not a very spectacular comet at this point. But it was very bright twilight. The sun was only about 5 degrees down at this point. So the first really good view that we had was on the morning of July the 6th, and this lovely picture from Peter Carson shows the comet in the morning twilight at about 3 a.m. BST, 2 a.m. UT. And it shows something that was characteristic of the comet that we'll come back to in a minute, which was that the tail had a dark band. You had the very bright coma and a dark band. At this point, what we're seeing is the dust tail. So we're seeing a lot of dust that's been ejected from the comet's nucleus as it got heated strongly coming around through perihelion. And that dust is beginning to flow out into space and form what would become a really spectacular dust tail. So quite a few people saw it on the morning of July the 6th. I was lucky on July the 7th, and you remember the Meteosat picture on July the 7th, there were only a few clear patches. I saw it in a small gap. I'd seen it on the 6th, and on the 6th it wasn't naked eye for me, but on the 7th it was certainly naked eye. It was so bright. I mean, I was really kind of excited having seen this. I cycled out to a nearby field, so I got a nice low horizon, and I was setting up and I was thinking, well, will I be able to see the comet? And at that point, the comet was behind this lower bank of cloud. And I just scanned around and I could see this kind of searchlight beam coming out from the cloud. And I thought, is that the comet? And then it rose out of the cloud, and there it was, definitely naked eye. It was sufficiently bright naked eye that as I was packing up and ready to cycle home, I could actually keep the comet visible naked eye as I was cycling back home. So that's pretty impressive. And it was already showing a really impressive tail. At that point, naked eye, the tail was 1 or 2 degrees long. It was looking really good, really good. For the first time, I mean, I haven't seen a comet that looks like this and since back in 2007 when 2006 P1 McNaught was visible to us briefly in the evening twilight. This was a very similar kind of view in the morning twilight. It was a kind of bright, almost searchlight beam, not that bright, but you could see it was this kind of fuzzy tail pointing up from the horizon. It looked very promising for this comet at this point. So I mentioned the effect that a lot of people imaged and drew, which is this dark lane behind the head of the comet. And here it is really nicely shown in an image by Richard Miles, and also in a wider field image by Ian Sharp. In historical documents, that's called the shadow of the nucleus, but it's not a shadow. It's not an effect of the nucleus shadowing the dust behind. It's because that the comet is very active, but the active sites are on the day side of the comet, so pointing towards the sun. So most of the material is coming out on the day side, and then solar radiation pressure pushes that material back down the tail. And it does that symmetrically. So you can imagine this is almost like a tube of material. And what we're seeing here is an optical density effect. So when we're looking through the edges of the tube, we're actually seeing more dust than if we're looking through the middle. It's a bit like when you're looking at a planetary nebula, which is a spherical shell of material, you actually see it brighter around the edges. And we're seeing the same thing in the tail here. So this is a characteristic of very active comets. So this comet was very active, pushing out huge amounts of dust. We now know that the nucleus is actually quite large. We know the nucleus of Neowise is probably somewhere around 5 kilometers across, which is a very large nucleus for a comet that came this close to the sun. And it was a very active nucleus as well, pushing out prodigious amounts of dust. Here's a really nice image of that close up by Finbar Connolly from Ireland, from God, Janice will have a go at me for this. Kilfannaigh or something in Ireland. She can pronounce it for me later on. But a really nice image again, showing this dark lane in the dust tail. You can also see the dust tail is asymmetric, so it's got a fairly sharp edge here and a much fuzzier edge here. And that's all to do with the trajectories that the dust particles are taking when they leave the nucleus and are pushed away from the nucleus by solar radiation pressure. And we'll see that effect in more detail in a minute. Lovely drawing here from Paul Abel showing the same thing, showing this dark lane, and again an image from David Strange showing the same thing. Now, one of the things that's come on a long way since the last time we had a really bright comet is amateur spectroscopy. And this is some amazing work done by Robin Ledbetter, taking a spectrum of this comet at fairly high resolution. And these two lines here are the D lines of sodium. So what you can see in the background, these faint two lines here, these are sodium from sources on the Earth, so street lights. And these bright lines are sodium from the comet. And you can see that they're slightly offset. They're slightly offset in wavelength. And the reason that they're offset is because the comet is moving relative to the Earth. And Robin's done a fantastic job here of looking at the Doppler effect that you get for that. So there's several Doppler effects that we see here. There's a Doppler effect due to the relative motion of the comet with respect to the Earth. And we see that in light that's emitted from the comet. So this sodium is actually emitted from the comet's tail itself. But there's also a Doppler effect that's due to the motion of the comet with respect to the sun and the comet with respect to the Earth. And we see that in light that's reflected. So sunlight that's scattered from the comet's dust actually has a different Doppler shift to the Doppler shift that we see in light that's emitted from the comet's tail. And Robin has actually worked out what all of these are and compared it with the ephemeris velocities that are given from JPL horizons. And the accuracy is really, really good. So solar velocity, he measures as 32 kilometers a second, and JPL gives 31.4. Velocity relative to the Earth is 55 kilometers a second, and JPL gives 54.9. And that's really impressive, I think, that amateur spectroscopy has now reached the capability of being able to do that. One other interesting thing from this observation is these very strong sodium emission lines, and we tend to see those only in very bright comets. So we saw them in Hale-Bopp back in 1997. And a number of images actually managed to image the sodium tail. So normally in comets, we say there are two kinds of tails. There's a dust tail, which is shining by reflected sunlight, which is this dust tail here. There's the ion tail, which is shining by fluorescence, which is the blue tail here. But also we had a yellowy reddish tail, which is the sodium tail of the comet. And that's shown very nicely in this image by Andy Wellington. And that tail moved in position angle relative to the other two tails, but shows up very, very well in the spectrum here. I showed the picture of noctilucent clouds earlier on. Of course, this comet came along at the peak noctilucent cloud season. And on the mornings of the 11th and on the 12th, we had some very strong NLC displays. And some observers got some fantastic images of the comet with the NLCs. We've already seen this one from Rob Bullen, but this is a lovely one as well from David Swan up in Tynemouth, just showing the comet and its lovely dust tail in the deep blue sky of the morning twilight, with noctilucent clouds down here in the foreground, and just for good measure, some wind turbines in the foreground too. So some fantastic images of this comet, but we've also got what I think is really lovely as well. We've had some fantastic visual observations too, and I really like this. This is a pastel drawing by Chris Nuttall from Bishopsthorpe in York, who went out into a cornfield and basically drew what he saw in the night sky, this lovely comet, the NLCs, and the blue of the dawn sky. And I think, you know, despite all of the developments we have in imaging and all the science we can do and all the spectroscopy we can do, it's just really nice to have these kind of human renditions of what it really means to be out there in the morning twilight and seeing a great comet like this hanging in the sky. So a lovely, lovely picture there from Chris. About this time, and we're now approaching the sort of middle of July, so this is the 12th of July, observers in really dark sites began to show the comet's tail in incredible detail and showing incredible length. And this is from an image taken by probably the master of comet imaging, Michael Jaeger, who took all his equipment up a mountain in Austria to get this mosaic of the comet. And what this shows is the huge dust tail. So right down here, right in the center here, is this 5 kilometer dirty snowball nucleus. And it's that dirty snowball nucleus that's responsible for everything else we're seeing. So an ion tail, which at this point was stretching maybe 20 degrees across the sky, millions of kilometers long. A dust tail, which was stretching something like 10 degrees and was showing tremendous detail. So you can see in this dust tail, we see these striations, and these striations are due to the way that the dust particles which leave the nucleus are actually orbiting themselves. So as each dust particle leaves the nucleus, it acts like its own little celestial body. It's moving under gravity around the orbit, but it's also perturbed by solar radiation pressure. And these dust particles leave the nucleus not in a continuous flow, but they leave the nucleus in pulses, depending on where particular active areas are with respect to the daylight side of the comet. And the dust particles have different sizes. And so the different sizes of dust particles are affected differently by solar radiation pressure. They're accelerated more or less depending on how big they are. And so you get this sorting down the tail into bands, and these lovely bands are seen again in very active comets. And in this wonderful image from Michael Jaeger here, you can see the dust tail, you can see it, the dust tail curving away with this fantastic detail in it. And you can see also the dust tail, this straight edge here down here is essentially an area where the dust particles, the lightest dust particles are being kind of blown away by solar radiation pressure. And that's a particular curve that you can draw on the sky there that reflects that part of the front of the tail. So there's a lot of physics going on in this tail. In the ion tail, what you can see is the effects of the solar wind. So the ion tail is ionized gas that's trapped in the solar wind's magnetic field. And so you see these clumps and bumps in the ion tail. And one of the things that you know that you can see from these photographs is that you need to take fairly short exposures. this ion tail, and you'll see it in a minute, is moving very rapidly. And so if you take longer exposures, it just gets blurred out. And that's the reason for having very fast optical systems and dark skies. If you try and overcome light pollution by stacking loads and loads of short exposures, you will just blur out all that detail. So one of the reasons to go up a mountain, but unfortunately there aren't any of those in Essex or Suffolk. So we found it much more difficult to pick up those tails. This is a picture from Martin Mobley, just to show what you can do with a very simple camera. This is a fixed camera on a fixed tripod. It's a very old camera, Canon 300D, from a reasonably dark part of Suffolk, I guess, but showing the dust tail here and the blue ion tail. This is my attempt from Chelmsford, which is much more light polluted, where I've stacked lots of images, so you can see the blue ion tail stretching quite a distance and the dust tail, but because I had to stack a lot of images, a lot of the detail you'd see in the Jaeger picture is blurred out. This is another example of spectroscopy from Robin, showing the differences across the different parts of the comet. So he was looking here in the Coma, the front part near the nucleus, and back down the tail. And there are two spectra here. So in the Coma, you can see there's strong cyanogen emission, there's strong emission from carbon, and that's what gives the Coma its kind of greenish color in photographs. And there's strong emission from sodium. Down the tail, you've got cyanogen again, but you've got these CO ions, which are the bluer color that you see in the ion tail, and then the sodium rather less. So again, spectroscopy has been a key thing, and quite a few people have submitted spectra into the BAA. The next journal is going to contain a short article by Robin on the spectroscopy he's done, but ultimately we'll be writing a paper on this comet, and spectroscopy will figure as a large part of the observations that we've got. The comet was by this time so bright that it was easy to catch in the sky. This picture on the left here is taken by one of my little night sky monitoring cameras that monitors the sky for meteors. Just a little tiny 30-pound camera, and there's the comet. It was showing really impressive detail to visual observers, and this is a drawing by David Graham showing the tails, and David was actually able to see the ion tail, sufficiently dark where he was to be able to see that, and details right in the inner Coma, which were often overexposed and lost in imaging data. So drawings still are really important because quite often images are overexposed in that inner Coma region. The comet was an amazing object on all kinds of scales. This is a lovely all sky picture by James Waitman showing what you could see in the sky on the 19th of July at almost midnight. You've got Mars over here in the east, you've got Jupiter and Saturn, which I'm sure we've all been looking at recently. And over here, opposite Jupiter and Saturn, low in the northwest, here's our lovely comet with the Milky Way stretching overhead. And the comet really was an amazing object in all scales by this time. Richard McKim was drawing it in binoculars, some lovely drawings that Richard has done showing details in the inner Coma and the inner tail region. Martin Ratcliffe sent this lovely image taken, I guess, from probably Kansas in the US, with the ion tail and this, again, the striations visible in the dust tail here. So keeping the exposure short enough that the detail wasn't blurred out. Nick Quinn got some fantastic images from Stenning in West Sussex on the southern end of the South Downs National Park, where it's fairly dark. This one is the one that was on the cover of the last journal, but he also got another one here. And this, look, is the bowl of Ursa Majors. So just showing you the kind of scale that we're talking about. The comet was down here in Lynx in southern Ursa Major, and the tail was stretching right up into the handle of the plow. This is probably my best image obtained on the 17th. Again, this time I was using rather than a DSLR, I was using an ASI cooled CCD camera on the back of a 100mm f2 camera lens. I could take short enough exposures here that I could again pick up a lot of detail. So you can see detail in the ion tail, and you can see these lovely striations in the dust tail. You can also see this effect as well, where at the front of the nucleus you have this curve, which is basically the front end of the dust tail, and that's all determined by the radiation pressure and particle sorting and orbits of each of those dust particles. So lots of science to do on these images and lots of science to write up. Lots of work for the Comet section director. So I'm pleased that these comets don't come along too often. It was lovely to see though. By this time, the comet was getting high enough that we could actually get telescopes with decent focal lengths on it, and these images by Richard Miles were processed with a particular filter called a Larsen-Sekanina filter, which emphasizes radial and circular detail in the inner coma. So it effectively removes the very bright coma itself, and it leaves you with the small variations in light due to effects in the inner coma. And you can see here there is a kind of spiral structure, and there are shells here in the inner coma. And anyone who can remember Hale-Bopp, and anyone who was lucky enough to look at Hale-Bopp in a large telescope will remember that Hale-Bopp had something very similar. It had these shells and spiral structures. And these relate to the emission of dust from the nucleus and the fact that the nucleus is rotating. So you can effectively see that. And this is one of my images processed with a very similar filter taken on the 20th. And what I can do is then run this as an animation. And I'm not sure how well this will work. It probably is a bit jerky, but if you go to the Comet section archive, you can actually see these videos running, and they actually show motion in the inner coma. On this one I can see on my screen, you probably can't, a spiral rotating around the nucleus here, and lots of activity moving up the tail. So go and have a look on the BAA image archive. You can get to that from the Comet section page. Have a look at some of these animations. They do show some very, very interesting motion in the inner coma and inner tail of the comet, and something that we only tend to see in very bright, very active comets. I'm not sure we know what the rotation period of the nucleus is yet. I've seen some estimates, I think in the range of 6 hours or so, but I'm not sure how secure those are. This is just that same image, but not processed, so that you can actually see motion down the tail. And this demonstrates why taking long exposures of the ion tail leads to effectively loss of detail, because this material is moving at about 400 kilometers a second. It's moving at the solar wind velocity, and so it's moving very rapidly down the tail. And if you take lots of short exposures and stack them to overcome light pollution, you just lose all of that detail. So by now the best was past. The comet had passed the Earth closest approach on the 23rd of January, when the tail had probably reached something like 25 to 30 degrees long, the ion tail, although it was very low surface brightness at that point, but it's visible in images taken from dark sites. The comet then started to move away from the Earth. We actually started to see much more of the inner coma, and you can see this kind of greenish turquoise color in the inner coma as the dust production fell and the coma began to become more prominent. So this is the emission from the swan bands in the inner coma. And the comet faded and faded, and this is an image, one of the last images that we've currently got in the archive from Martin Mobley, taken on the 18th of August. By then, the comet had become more easily visible in the southern hemisphere again, but this is an image showing it moving through the galaxies in Virgo. So the big question, was it a great comet? I'm not so sure it was. It was a really spectacular comet. It was a really nice comet. This is a light curve that Jonathan Shanklin has generated from observations submitted to the BAA, showing it probably reached about first magnitude at the beginning of July. It certainly had a very impressive tail, and it certainly was something which was very impressive to look at. Probably the best comet I've seen since Hale-Bopp in 1997. But I would have counted Hale-Bopp and Hyakutake both as great comets because they really were bright and spectacular objects. This comet was really good, but I would put it maybe one division down from a great comet. But I'd be interested to hear what other people have to say on that. That's not to take anything away from it. It was a really impressive comet. It's also probably one of the best imaged comets that we've had because it's the first really bright comet that we've had since everybody has had really high quality digital cameras that they can point at it, all the way from iPhone cameras to kind of modern DSLRs and mirrorless cameras and cooled cameras, which is why we've got so many images of it. And if you want to have a look at some of those images, go to our image archive. So Dennis manages the image archive. It's available through the Comet Section website. It's intended to be a permanent archive of Comet images. It goes back probably 100 years or so, but this is probably one of our most imaged comets. The last time I looked, there were something like 260 odd images in the 2020 F3 gallery. So if you want to see any of those images, go there. The movies and animations are there as well. Thank you to everybody who submitted observations to the BAA of this comet. There were a huge number of people who did. There's no way I can show all of your pictures in this talk, but there is a notes and news article coming up in the next BAA journal, which is rather long for a notes and news article, and hopefully all your names are in there and some carefully selected images. And then the plan is to write a much more detailed paper on this comet, to have it appear hopefully within the next year or so in the journal, to actually reflect the science that we've managed to get as amateur observers from this fantastic comet. So I think it definitely was third time lucky. I think Michael Matasio was absolutely right when he saw this comet approaching the sun from the southern hemisphere as a really good chance for us. But I don't think any of us could have predicted at the beginning of July how good this comet was, and just how exciting it was to get up in the morning and see this amazing object rising out of banks of cloud into a lovely dawn sky with all the NLCs and things there as well. So happy to open it up to questions now, but Dennis, I don't know whether you want to just say anything quickly as to how you would see this comet comparing with comets in the past, given that you actually unfortunately didn't really get to see it in a very clear sky.
No, I didn't get to see the comet very well, although I did see it on 2 or 3 occasions in binoculars, and it really was a very nice looking comet, a very beautiful comet and really well proportioned, wasn't it? I think in terms of its rank, I would probably place it a little bit less impressive than what you described there. I think if you look at the brightest comets that have ever appeared, then you put something like the Kreutz sun grazers in Ikea Secchi, which was about -10 at perihelion, as being the brightest of the bright. And then you would look at comets like Hale-Bopp and Comet Vest in 1976 as being extraordinarily bright comets and probably on the verge of being a great comet. I think this comet was probably something in terms of somewhere between Pan-STARRS 2011 and Comet West. It was probably in the 3rd or 4th rank, but it was a beautiful comet, and it really did impress when you saw it with both the naked eye and with optical aids. It was also very reminiscent, and people said this, it looked like Bennett's comet in 1970. There were quite a few comparisons with Bennett's comet. And what I thought was one of the most striking images of it was looking at it in comparison to Donati's comet over Paris, because some of the pictures that I have seen when I've been collecting them for the BAA archive look very similar to Donati's comet over Paris. And there's a few images in there in the archive which you might want to look at and make your own mind up about that. One of the other things I'd say about the comet was, because it was discovered by Neowise, we knew it was coming long before it arrived. But really, if we hadn't have had the spacecraft images there, it was a prime candidate for an amateur discovery. Probably from the southern hemisphere, and somebody like Bill Bradfield would have discovered that comet as it came in from the southern hemisphere. But if it had been missed in the southern hemisphere, then somebody like Alcock or one of the other comet searchers like Denning would have probably picked it up in the sky, or even the Americans who would have been searching at the same sort of times. So it was a fantastic comet. It displayed all the attributes of a nice comet, but I don't think it made the ranks of a great comet. I still think that we're still waiting for that great comet to appear in our skies. And even Hale-Bopp, even if Hale-Bopp had, when we saw that was a great comet, it wasn't the greatest of the great. I think that we need to wait to see another big sun grazer for that to be the case.
Yeah. And I think you're probably right. I mean, I think one of the things that maybe distorts our opinion is that we've been waiting so long for a really good comet.
I was quite interested in a comment that you made actually not too long after you had your best view of it, and you said that you finished the night and it was one of the best nights of your astronomical career, so to speak. It was It was so emotional that you saw this comet in the particular way that you did see it, and I was surprised about that because you've been stood on top of Tedy watching Hyakutake stretch from horizon to horizon almost, and yet you still describe this comet as being very emotional for you.
I said one of. I mean, the seeing Hyakutake from the top of Tedy was extraordinary, and probably is the best comet I've ever seen. I mean, it had a 30-degree tail that you could see with the naked eye. It was overhead. It was a kind of really emotional thing to see. It was quite a scary thing to see in the sky, and you could imagine how people in the past who didn't know what comets were would be rather kind of worried by that. So yeah, that definitely was at the top. But it was just that the particular night, and I think it was the Friday night, Saturday morning. It was one of those lovely nights where it was warm. It was that kind of deep blue twilight that you get throughout the night in the middle of the summer. There was a fantastic display of NLC. There was Jupiter and Saturn, and Mars and the Moon came up later, and then there was this comet, and it was there, and it really was, to me, just an amazing experience. That night I didn't really have any idea quite how good the comet was going to be. And I remember getting there and seeing it and just watching the comet gradually rising as the sky got brighter, and seeing the noctilucent clouds and things too. So yes, I would put it pretty high up there with my observing experiences in my life.
And I just come in, and Peter Carson makes a very relevant point there, that he's saying it perhaps is not one of the most memorable because nowadays, of course, we have so much better equipment with which to capture them, electronic cameras and so on and so forth, so that when you do look back, and I look back through the archive pictures there, you know, you have to take into account that people were messing about with film and stuff like that. But I agree with you, Nick. I mean, it takes a lot for me to stay up all night and observe. And it was just the whole setting, the fact that there was so many other things going on in the sky at the time. It made it really interesting. So you'd look at the comet, you'd look around, you'd look behind you to see what the other planets were doing, and and then an hour later something else had come up. So from a sort of less professional point of view, I have to say I thought it really was spectacular, and it was really good to see.
Nick, do you think it was a bit more of an astronomer's comet because there wasn't so much attention from the media? It was sort of like our comet, wasn't it? We had it to ourselves. The general population wasn't out there on every hillside trying to find it, and it was more a private sort of comet for us, I thought.
It was interesting because certainly the media, and you'll have seen in stuff I've given before, the media will often print absolute rubbish about comets. And we had for 2020 F8 Swan, there was a kind of big article on it being the comet of the century and all this kind of stuff. So firstly, I'm not sure whether the media just tired of all of this and thought, well, okay, we've predicted these things so many times, we won't bother with this one. Or maybe it's just that amateur astronomers and astronomers in general didn't big it up as much as maybe they do, because partly we're to blame. You know, the media catch on to these things because we as amateur astronomers get all excited about them. Yes, maybe you're right. It was I mean, I certainly had occasions where I had friends and family, and I tried to get them to look for the comet, and unless you were actually there with them and could point it out, most of the time they couldn't find it. So, you know, to me,
which wasn't the case with Hale Bopp.
No, it wasn't.
The whole
Hale-Bopp,
population saw Hale Bopp, and they mentioned it and they remember it. Even today, people, even though they get it mixed up with Halley and they call it Halley Bopp, you know, they still remember Hale Bopp as a very bright comet.
I remember when I edited some stuff for the TA magazine for those two comets in 96 and 97, and I came up with my own definition of what a great comet was, which was that it was a comet that caused a traffic hazard. Because I remember driving on the windy roads on Mount Teide in Tenerife and being distracted by this bright comet in the sky that I could see out the window of the car. And I also remember for Hale Bopp, we had observations submitted to TA from the hard shoulder of the M3, where a person I won't name, had stopped to make an estimate of the comet because they saw it as they were driving home. But I think it was kind of, there's a comment from Owen on there, which would be interesting to address in a sec. I think we kind of think that it was a really prominent thing to see. And for me, it was, you know, you just set up your camera and before you were even dark adapted, there it was. But I know that work colleagues and friends and others who aren't astronomers, I tried to give them very specific instructions as to how to find it. And it wasn't that difficult to find. You know, you found Auriga below the pole star, you went left a bit and there it was. And they found it really, really difficult to find it. And I think in one way, they were being misled by some of the photographs that I'd sent them, the images, where they expected this thing to be bold and visible on the sky, and they couldn't see that. But in another, I think we just kind of overestimate how obvious something is in the sky because we know what's supposed to be there and we know what we're looking for. And for a person who doesn't,
which is what you said, it wasn't a great comet.
I think that's right. There's a few messages. Janice, have you got the chat screen open?
Yes, just coming in now. There's nice comment from John Axtell. Thank you very much, Nick. Given the size of its dust tail, it will have lost quite a bit of its material into that tail. Has an estimate been made in this regard, perhaps as a percentage of its mass that it has lost?
Not that I've seen, but this is a comment you often get with comets. I mean, there was a huge amount of dust put out into the dust tail, but if you think of the mass of a 5 kilometer diameter comet nucleus, there's a huge amount of mass there. And I guess the best answer I could give is that we know for a comet of a similar diameter, which didn't get anywhere near as close to the sun, but for 67P, the comet that Rosetta went to, it was a similar diameter nucleus and it lost a few meters off its surface at perihelion. So this comet probably lost maybe tens of meters or something like that. But you can do a lot of passages around the sun if you're 5 kilometers across, even if you're losing 10 meters of diameter each time. There's a comment from Owen there on the chat, which he says, I think you may be misjudging how social media pushed this comet, and many of the Facebook groups I were on suggesting that many more members of the public may have seen it than you think. Well, I know a lot of people did, and I saw a lot of pictures on Facebook that people had taken with simple cameras. So yes, I guess I'm not sure how many. So one thing I would say is that it's a lot easier to photograph something than it is to see it. So I think if people knew approximately where to look and pointed their camera in the right direction, they could get quite a nice picture, but maybe didn't see it. I may be misjudging it, but certainly just from my experience of people that I know who are not amateur astronomers how difficult it was to actually get them to find it, even when it had moved into the evening sky and they didn't need to get up at 2 o'clock in the morning.
But I think the problem with a lot of the social media outlets are that you tend to join those that you're interested in, and so it may be on all the things that perhaps Owen would look at, because they're going to be more astronomy based and general sort of social media groups. But I think also it's a bit worrying that you can point out to somebody and say, find the plough, because that's what your non-astronomy friends might know, and then look down from there, and they're still going, where's the plough? So
well, I think
that's very low level.
That's an unfortunate consequence, I think, of light pollution now as well, is that people are growing up.
Nick, I don't remember hearing on the TV news or in the newspapers much of a mention of this comet, and that's unusual, because usually they're onto it like it's a hot potato, aren't they? They're trying to push it as much as they can. There
were some other things going on in June and July, weren't there? I mean, I think COVID has kind of almost completely hijacked the news agenda for pretty much anything. So I think it would have been crowded out by lots of other stuff. I mean, I don't know. I mean, you're right. There wasn't very much in the media. You would have expected something, but there wasn't.
It's good.
Well, the latest findings on Venus only made the front page, the top line, for half a day, and then got kicked off again. So
yeah.
There's a few other comments here, Nick. And
yeah, sure, go.
So David Swan is saying, I thought this comet was an advert for binos. Non-astronomers who I go out to have a look with were very impressed with 10 by 50s.
Yeah.
Same here. I've got a good bird watching 8 by 42s, and it looked beautiful in those. So it really did.
I think that's absolutely right as well. And I think, whilst people might think they want a bigger and bigger telescope for something like this, which is a large extended object, good binoculars are worth every penny, and worth investing in a good pair of binoculars.
Absolutely, yeah. And David Strange comments, Dennis, that the NLO were on the news at 10.
The NLO deserve to be on the news at 10.
Hopefully for a good reason.
Yeah.
No, I know. I think I watched. I clicked through something that David posted on the BAA website, which was through to a YouTube clip from that News at 10 piece. So yeah, that was very good. Well done to them.
Yeah, we got a comment on the YouTube site from Honor Wheeler from that illustrious club called Crayford Manor House Astronomy, Dartford. Hi, Honor. She's saying, for me, this comet was a slow burner for the public, and I found a number of people had a greater appreciation in finding it when it was being pointed in the rough direction of where it was. So.
Yeah, and I think that's a key thing, that if you were actually with a group of people and you pointed out where it was and you could explain to them what they should see and you could help them, then they could find it and they could see it. The problem I was having was trying to kind of remotely tell people where to look on WhatsApp and other things. And I think if they were then trying to look without somebody there who knew what they were looking for, my experience at least was that they were finding it really hard to find. I mean, some people not. I mean, some people who, there's a whole range of people, some of whom seldom look at the sky and don't really know what should be there and what shouldn't be. They're still interested, but they probably wouldn't know a comet if they found it in the sky. And then there are others who are much more attuned to nature and could find it even if they weren't astronomers. I think it depended on where you were as well. I mean, obviously, if you were out in the countryside, it was much easier to see than if you were trying to see it from the middle of a city or a town. And I think that's one of the other things about great comets, that in the bar for being a great comet is possibly getting higher and higher, because more and more of us are living under light pollution, and so it's more and more difficult to actually see these things in the sky. They need to be brighter in order for us to be able to see them.
Absolutely. I think that's the sum of all the questions. I don't see anything else coming in at the minute. Nick? It's coming up to 8 o'clock. I don't know if
Yeah.
you want.
No, I think so. We'll call it a day at that. So hopefully everybody who tuned in found that interesting. Certainly a very impressive comet, and I had no idea back in the end of June that we were actually going to see something like this. So I think we've been very lucky this year, and we were pretty lucky across the country with the weather as well. If anyone's got any observations or images of the comet that they haven't yet submitted to the section, then please send them in. They will all be archived, and as I say, the next journal contains both a summary of the comet that I've written and a summary of the spectroscopy that Robin Ledbetter's written. So it should be a good selection of comet stuff in the next journal. Thanks to Philip, who's made the space for us. So thank you.
Before you run off, Nick, I think I'd just like to mention our next webinar on the 30th of September, same time, same place, 7 o'clock in the evening. And that's going to be on observing occultations, and is being delivered by Tim Hames, who is the Assistant Director of Occultations BAA Asteroids and Remote Planets section. So that sounds very interesting. Look forward to hearing Tim.
Does indeed. So yes, thank you very much for pointing that out, Janice. So that'll be when did you say it was? The 30th of September. Yeah, okay, yeah, good. So hopefully everybody enjoyed that. I shall now work out how to close all of this down and turn off the YouTube stream and everything else, and it'll be ready to view on the YouTube if you want to watch it again, or if you've missed any of it in an hour or two, I suspect. Right, good night everybody. And thank you very much, Dennis and Janice, for supporting me as panelists.
Welcome.
Good to hear.
Thank you.
Okay, Nick.
See you.
Right, which button do I press?
Not the nuclear one.
No, well, I don't have access to that.
One.
But I know a man who does.
Yes.
Unfortunately.
Scary, isn't it? Right.